Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. We are group 5 from section 3 from course BEJ 10403 Electric Circuit 2. In this video, we are going to show how to perform circuit analysis technique for a given network problem. Our objective is to solve the current and voltage response of second order circuit, to solve steady state expression using various circuit analysis technique, and to demonstrate the simulation for second order circuit and steady state current or voltage. Question 1. A mechanical system is represented with an RLC circuit as shown in figure 1. Assume a current source IS of 5 ampere is applied to the circuit. Assume the initial current IL0 and the initial capacitor voltage VC0 are both 0. Design the circuit to obtain an overdamped, critically damped, and underdamped response. For the design, choose the undamped frequency in the range of 100 until 1000 rad per second. So our group decide to choose 750 rad per second for our simulation. And then simulate the circuit design to get the individual response plot and combination of all response plot on a single graph. So this is our circuit for question 1. We use Proteus application to simulate our circuit. The first circuit here is critical damped where alpha is equal to omega. The second circuit is overdamped where alpha is more than omega. Then the third circuit is underdamped where alpha is lower than omega. To create the circuit, we take the inductor, capacitor and resistor component and place it just like in the question, the circuit in the question, and then we put the value of inductor and capacitor and resistor. For the value of inductor and capacitor is the value we get from the equation as shown earlier, which is inductor is 26.67 millihenry and capacitor is 66.67 microfarad. Meanwhile, for the value of resistor, the value is different for each circuit in order to get the different value of alpha. The first circuit is 10 ohm, the second circuit is 5 ohm, and the third circuit is 20 ohm. And then we put the pulse generator, setting it with current source, and the value is 5 ampere. Same to all circuit. Afterward, we put the probe, the voltage probe above capacitor and the current probe below inductor. To simulate the graph, we just click and put the probe into the analog graph. What is it called? Analog graph. And then second circuit, okay, so each the question asks student to create the graph for each circuit that have VT and ILT, VCT and ILT, and then a combination of VCT of all graph and ILT of all graph. So first we put the voltage VCT, combination of all graph or all circuit. And then ILT from all circuit. Oops, sorry. Alright. And then we just first we need to setting, but I believe I already setting, yes, I already setting all the graph into 50 milli stop time. So all I need is just simulate the graph. Simulate the graph. Simulate the graph. Alright, there. So from this we can see the shape of each graph for each circuit. and the shape of graph for the combination of all VCT and all ILT. Okay, so for question D, to analyze the shortest time required to reach 80% of the final value of VCT, first we maximize the graph windows, and then put the cursor into the top of the graph, the most top you can see. So for the first circuit, the critically damped circuit, VCT shows here is 37.4. To get the 80% of the value is to get the time required to reach 80%. First, we take this value, multiply with 80%, we get 29.9, and then so we move the cursor until it reaches 29.9, and then look at the time it shows at the bottom corner on the left. We get the value is 635 micro. And then we do the same for the second circuit. Maximize the graph windows, put the cursor at the top, we get the value is 22.5 volt. Multiply with 80%, we get 18. Move the cursor until it reaches 18. 18. Look at the time and we'll get the value. The time required to reach 80% of final value is 448 micro. And then at the last circuit, put the cursor at the top, same, 55.3, multiply with 80%, we get 44.2. 44.2 is right around here. And look at the time, we get 870 micro. So that's all. Question 1b. Find the expression of VCT and ILT for t more than 0 for each of your circuit design. Show all your calculations. The first calculation is critically damped, where the final answer of ILT for critically damped is 5 plus open bracket -5 -3750 T close bracket exponential power of -750 T ampere. And then VCT for critically damped is open bracket 100 plus 75.01 K T close bracket exponential power of -750 T volt. Next is a calculation for overdamp. The final answer for overdamp ILT is 5 minus 5.387 exponential -201 T plus 0.387 exponential -2799 T ampere. And VCT for overdamp calculation is open bracket 28.89 close bracket exponential -201 T minus exponential the power of -2799 T volt. And lastly is the calculation for underdamped. The final answer for underdamped calculation ILT is 5 plus exponential -375 T open bracket -5 cos 649.51 T minus 2.89 sin 649.51 T close bracket ampere. And then the VCT for underdamped is -10 exponential power of -375 T open bracket -5 cos 659.51 T minus 2.89 sin 649.51 T close bracket plus exponential the power of negative 375t, open bracket, 3247.55 sine 649.51t minus 1877.08 cos 649.51t, close bracket, volt. Next, we will go to question 2, which will presented by Intan.
Assalamualaikum, my name is Intan Nur Anis binti Nur Azman, CE 230025. For question 2, given sinusoidal sources Bs equal to 30 sin omega t and Is equal to 10 cos omega t, where omega equal to 400 rad per second. Solve the steady state current and voltage expression IA, IB, IC and VT using any two circuit analysis technique, for example nodal, mesh, source transformation and etc. So our group used mesh and nodal analysis to solve the current and voltage expression. So this is the calculation for nodal analysis for question 2. So the answer that we get from using the nodal analysis technique is IA equal to 9.75 ampere, IB equal to 0.08 ampere, IC equal to 0.64 ampere, and for VT we get 0.08 volt. And then we go to mesh analysis. So this is the calculation for mesh analysis for question 2. The answer that we get from using mesh analysis is IA equal to 10 ampere, IB equal to 0.04 ampere, IC equal to 0.58 ampere. For VT, we get 0.07 volt. For question 2C, plot the steady state currents and voltage response IA, IB, IC and VT. Today I will explain about the simulation for the sinusoidal steady state circuit in question 2. As we can see here in Proteus, this is the circuit for the sinusoidal steady state. So this is the generator for the circuit. This is the current probe for IA, for IB, for IC, and this one is voltage probe for VT. So the frequency that we use in this circuit is 63.66 Hz. As we can see in the question, the W they already given, which is 400 rad per second. To get the value of frequency, we can use the equation of W equal to 2 pi f, and then we just insert the value and calculate the frequency to get 63.66 Hz. And then we will run the circuit. As we can see, the AC voltmeter over here is 0.13. And for the graph, we will take this one and then we will drag this current probe into the graph. Current probe for IB and current probe for IC. So we will set the stop time for the graph is 150 milli. Then we will stimulate the graph to see the plot for IA, IB, and IC. As we can see over here, IA, we get 10 ampere, the same as we get in the calculation, which is 10 ampere also. And for IB, we get 45.0 milliampere. We will convert it and we will get 0.04 ampere, same as we get in the calculation over here. Meanwhile, for the IC, we get 1.49 ampere in the graph, and the calculation we get 0.58. So the value is near to each other.